How to Lie with Statistics, by Darrell Huff. Introduction. Imagine for a moment, it's some years after the great class of 1924 graduated from Yale University. A report comes out, and it makes headlines. It states, with surprising precision, that the average graduate from that class is making $25,111 a year. Now, back then, that was an astronomical sum of money. The kind of money that makes a parent think, that's it. My child is going to Yale. It sounds like a guarantee for a prosperous life. But let's pause. Let's look at that number again. $25,111. Doesn't that feel a little too perfect? How could anyone possibly know the average income of a widespread group of people down to the exact dollar? Most of us would have a hard time pinning down our own income that precisely, let alone that of thousands of others scattered across the country, with investments and side businesses and all the complex ways people earn a living. And that's the moment the magic trick begins. A number, dressed up in the costume of scientific precision, is presented to the world. It's a number that feels true, because numbers aren't supposed to lie. But they do. Oh, they lie all the time. They can be manipulated, twisted, and framed to tell you almost any story someone wants you to believe. This is the world that a brilliant writer named Darrell Huff decided to expose back in 1954, in a slim little book that has become more important with every passing year, How to Lie with Statistics. This isn't a textbook for mathematicians. It's a survival guide for the rest of us. It's a decoder ring for the modern world, a world saturated with data, charts, and figures all screaming for our attention. Huff wasn't a professional statistician. He was a journalist with a keen eye for how language and numbers could be used to persuade, and sometimes, to deceive. He wrote this book as a manual for self-defense. He believed that the crooks, the advertisers, the politicians, they already knew these tricks. It was honest people who needed to learn them, not to become liars themselves, but to avoid being fooled. And today, his message is more urgent than ever. We are bombarded with statistics every single day, on our phones, in the news, from people trying to sell us a product or an idea. So, my promise to you is this: by the end of our time together, you will have a new kind of vision. You will be able to look at a statistic, a poll, or a graph, and see the story behind the story. You will learn the secret language of data, and you will become nearly impossible to fool. This isn't just about numbers, it's about learning to think clearly in a world that often tries to confuse you. So let's begin. Book summary. The first and most important secret to understand is that nearly every statistic you've ever seen is born from something called a sample. If you want to know exactly how many red and white beans are in a giant barrel, there's only one way to be perfect: count every single bean. But of course, nobody has time for that. So, we do the next best thing. We reach in, pull out a handful, and assume that the proportion of red to white beans in our hand is the same as the proportion in the whole barrel. That little handful is our sample. And if that sample is chosen well, it can tell us a great deal about the whole barrel with remarkable accuracy. But if it's chosen poorly, well, that's where the lies begin. This is what Huff calls the sample with the built-in bias, and it's the original sin of bad statistics. Think about it this way. Imagine a newspaper wants to prove its readers are more knowledgeable than the general public. A professional polling organization, like Gallup, might spend a great deal of time and money to carefully select a cross-section of the entire population to interview. They might find that a third of people have never even heard of the metric system. But the newspaper takes a shortcut. They print a coupon in their paper and ask readers to clip it out and mail it in. When their results come back, they proudly announce that 98% of their readers know all about the metric system. See the trick? Who is most likely to see that coupon, care enough to fill it out, and spend a stamp to mail it in? The people who are already interested and informed on the topic. Everyone who didn't know or didn't care simply ignored the coupon, effectively removing themselves from the sample. This is called a self-selected sample, and it's almost always biased. It doesn't reflect the newspaper's readers. It reflects the small, motivated group among their readers who chose to participate. This brings us back to that dazzling Yale salary. How did they arrive at $25,111 a year? The number came from a survey sent out to the graduates. But who is most likely to respond to a survey about their income a quarter century after graduation? First, you have to find them. The university has lost touch with many of its alumni over the years. Who are the lost ones? Are they the titans of industry, the Wall Street executives? Probably not. Their addresses are easy to find in directories like Who's Who. The lost alumni are more likely the ones who haven't been so successful, the clerks, the struggling artists, the people who haven't exactly fulfilled their shining promise. This group, which would pull the average down, is largely missing from the sample to begin with. Second, of the people they do reach, who is most likely to fill out the form and mail it back? The ones who are proud of their income. The person who feels ashamed of how little they make is far more likely to toss that questionnaire in the wastebasket. So the final sample is made up of the most successful graduates whose addresses are known and who are happy to brag about their income. The result, $25,111, is not a reflection of the average Yale graduate, it's a reflection of the most successful and vocal ones. The sample had a massive built-in bias. This bias shows up everywhere. A psychiatrist might report that nearly everyone is neurotic, but his sample is made up entirely of his patients, people who came to him precisely because they were struggling. You have to ask yourself, who did they talk to? If the sample is flawed, the conclusion is worthless, no matter how precise it sounds. The most famous example of this was the Literary Digest poll in 1936. They polled millions of people and confidently predicted that Landon would overwhelmingly beat Roosevelt in the presidential election. They were spectacularly wrong. Why? Because their sample was drawn from telephone directories and magazine subscription lists. In 1936, during the Great Depression, people who could afford phones and magazines were, on the whole, wealthier than the average voter, and they were far more likely to vote Republican. The sample was economically biased, and it elected a president who, in the real election, didn't stand a chance. So the first question you must always ask when you see a statistic is, where did the data come from? Was the sample random, or was it biased from the start? Because if the foundation is cracked, the entire house will fall. Now, let's say someone has a perfectly good, unbiased sample. They can still lie to you. One of the most elegant ways to do this is by using the word average. Imagine I'm an estate agent trying to sell you a house in a new neighborhood. I lean in conspiratorially and tell you, you'll love it here. The average income is about £10,000 a year. You're impressed and you buy the house. A year later, I come back, this time as part of a committee trying to stop a tax increase. I hand you a petition and say, we have to fight this. After all, the average income in this neighborhood is only £2,000 a year. Were you lied to? No. Both of those figures can be perfectly legitimate, legally calculated averages from the exact same data. The trick is that the word average is incredibly slippery. It can mean three different things: the mean, the median, or the mode. The big, impressive £10,000 figure was the mean. This is the average we're most familiar with. You get it by adding up everyone's income and dividing by the number of people. The problem is that the mean is easily skewed by outliers. It turns out that most of your neighbors are humble farmers and retirees, but there are 3 millionaires who live on the hill. Their massive incomes pull the mean way up, creating a number that is far higher than what almost anyone in the neighborhood actually earns. This is a case where nearly everybody is below average. The smaller 2,000 pounds figure was the median. The median is the number in the middle. If you lined up everyone in the neighborhood by their income, the median is the income of the person standing right in the center. Half the people earn more, and half the people earn less. It's a much better representation of the typical person's experience and isn't distorted by those millionaires on the hill. Then there's the mode, which is simply the number that appears most frequently. If more families earn 3,000 pounds than any other single amount, then that's the modal income. So when a company boasts that its average employee's salary is $75,000, you have to ask, which average? If it's the mean, that number could be heavily skewed by the CEO's multi-million-dollar salary, while the vast majority of workers make far less. If it's the median, then you know that half the employees make more than that and half make less, which is far more revealing. Whenever someone uses the word average without telling you which kind, they're often choosing the one that makes their case look best, and you should be immediately suspicious. But the lies don't stop there. Some of the most deceptive statistics are the ones that rely on what's not there. Huff calls these the little figures that are not there. You've seen the toothpaste ad. Users report 23% fewer cavities with Sparkle Bright. It's certified by an independent lab and everything. Sounds convincing. But if you hunt for the fine print, you might discover that the test group consisted of just 12 people. With a sample that small, almost anything can happen by pure chance. If you toss a coin a dozen times, you might get 8 heads, but that doesn't prove the coin is biased. It's just random fluctuation. The Sparkle Bright company could run a dozen of these small tests. 10 of them might show no effect or even more cavities. But by the laws of chance, one test is likely to show a dramatic improvement. So what do? They throw away the 10 results they don't like and trumpet the one result that makes a great headline. They're not lying about the result of that one test, they're just failing to mention all the others. Another missing figure is the measure of reliability or probable error. This is especially important with things like IQ tests. Let's say one child, Peter, has an IQ of 98, and another, Linda, has an IQ of 101. It's easy to conclude that Linda is the smarter child. But any good IQ test comes with a probable error. The Stanford-Binet test, for example, has a probable error of about 3%. This means Peter's true score is likely somewhere between 95 and 101, and Linda's is likely between 98 and 104. When you look at those ranges, they overlap. It's entirely possible that Peter's true IQ is actually higher than Linda's. The small 3-point difference between them is statistically meaningless. But because the little plus or minus figure is left out, people make all sorts of conclusions that are pure nonsense. A difference is only a difference if it actually makes a difference. This leads us to one of the most powerful forms of statistical lying: visual deception. The human eye is a powerful but easily fooled instrument. A graph can take a tiny, insignificant change and make it look like a world-shaking event. Huff calls this the gee whiz graph. Let's say a country's national income went up by 10% over a year. If you draw an honest graph, with the vertical axis starting at 0, you'll see a gentle, steady, upward slope. It's a nice improvement, but not breathtaking. But what if you want to create some drama? Simple. You chop off the bottom of the graph. Instead of starting the axis at 0, you start it just below the lowest point of the data. Now, that same 10% increase that once took up a tiny portion of the graph suddenly shoots from the bottom of the paper to the top. The visual impression is of an explosive, monumental boom. You haven't changed a single number, but you've completely distorted the story the data tells, just by manipulating the picture. You can make it even more dramatic by stretching the vertical axis. Let each notch represent a smaller and smaller value. Now your line will climb at an even steeper, more heart-pounding angle. This is done all the time in corporate reports and news magazines to make small gains look huge or small dips look catastrophic. Another visual trick is the one-dimensional picture. Let's say the average weekly wage in country A is £15, and in country B it's £30. To show this, you could draw two money bags. The honest way is to draw two money bags for country B and one for country A. But that's not dramatic enough. So instead, you draw one money bag for country A, and a second money bag for country B that is twice as tall. The problem is, when you make it twice as tall, you also make it twice as wide to keep the proportions right. Suddenly, the second money bag takes up 4 times the area on the page. And since a money bag is a three-dimensional object, the viewer subconsciously perceives it as having twice the thickness too. The volume of the second bag is now 8 times the volume of the first. The numbers say 2-to-1, but your eyes scream 8-to-1. You've used a picture to plant an exaggerated impression in the viewer's mind, and it's a trick that is incredibly difficult to resist. Finally, we arrive at the most subtle deceptions of all, the ones that aren't in the numbers or the pictures, but in the logic connecting them. The first is the semi-attached figure. This is when you prove one thing and then pretend it's the same as something else. The classic example is the mouthwash that killed 31,108 germs in a test tube in 11 seconds. The statement is true. The laboratory report is real. But what does it have to do with curing your cold? Almost nothing. A chemical that kills germs in a glass tube might be completely ineffective in the human throat, especially after it's been diluted. And who's to say those germs were the ones causing your cold in the first place? The statistic is impressive, but it's attached to a conclusion that it doesn't actually support. You see this in safety statistics too. More people are killed in airplane accidents today than in 1910. This is true. But does it mean planes are more dangerous? Of course not. It just means millions more people are flying today. The raw number of accidents is a semi-attached figure. The relevant number is the accident rate per million passenger miles. This leads us to the granddaddy of all logical fallacies, the one Huff calls post hoc rides again. The full name is post hoc, ergo propter hoc, which is Latin for after this, therefore because of this. This is the mistake of assuming that if two things happen together, one must have caused the other. Someone once did a study and found that college students who smoked cigarettes got lower grades than non-smokers. The conclusion jumped to was obvious: smoking makes you less intelligent. But is that the only possible explanation? Couldn't it be the other way around, that getting low grades is stressful and drives students to smoke? Or, far more likely, couldn't a third factor be responsible for both? Perhaps the kind of student who is more social, more rebellious, and less focused on academics is also more likely to pick up smoking. The correlation is real, but the conclusion about cause and effect is completely unproven. You can find these spurious correlations everywhere. There's a real statistical correlation between the salaries of Presbyterian ministers in Massachusetts and the price of rum in Havana. Does one cause the other? No. Both are influenced by a third factor: the general, worldwide inflation of prices and wages over time. This fallacy is used to prove that a college education causes higher income. It's true that college graduates, on average, earn more. But they don't necessarily earn more because they went to college. Colleges tend to attract two groups of people disproportionately: the very bright and the very wealthy. Bright people might have earned more anyway, and wealthy people have connections and resources that give them a head start in life, whether they get a degree or not. The college degree might just be a symptom of pre-existing advantages, not the cause of future success. The world of statistics is a minefield of these logical traps. And realizing that is the first step toward true intellectual freedom. You begin to understand that a number, no matter how authoritative it seems, is only the beginning of the story, not the end. Commentary. When Darrell Huff wrote this book in 1954, He was fighting against the slick persuasion of newspaper ads and corporate reports. He couldn't have possibly imagined a world with the internet, with social media, where every single one of us is both a consumer and a publisher of statistics. A world where a misleading chart can be created in seconds and shared with millions in minutes. And yet, the very simplicity and timelessness of his warnings make this book more essential today than it has ever been. Bill Gates himself has called it more relevant than ever, and he's absolutely right. We are swimming in an ocean of data, and we're often told that the data doesn't lie, but Huff teaches us a more profound truth: data doesn't speak for itself. It is always presented by someone with a point of view, an agenda, a product to sell, or an argument to win. The numbers themselves may be true, but the story they are used to tell can be a complete fabrication. The real power of this book isn't in turning you into a cynical person who distrusts everything. It's in turning you into a discerning one who questions things intelligently. It gives you a toolkit for thinking, a set of simple questions you can apply to any statistic you encounter, whether it's in a news article, a politician's speech, or a post from your favorite influencer. Huff outlines these in his final chapter, and they are worth committing to memory. They are your shield. First, who says so? Look for the bias. Is the source trying to sell you something? Is there a hidden agenda? Is a reputable name, like a university, being used to endorse a conclusion it never actually made? Second, how do they know? Look at the sample. Was it big enough? Was it representative? Or was it biased from the start? An enormous amount of nonsense is built on the foundation of a shaky sample. Third, what's missing? Are they telling you the sample size or the probable error? Are they telling you which kind of average they used? Often, the most deceptive part of a statistic is the crucial context that has been conveniently left out. Fourth, did somebody change the subject? Are they reporting the number of germs killed in a lab and implying it will cure your cold? Are they using a shocking raw number when the more relevant figure, the rate, would tell a different story? And finally, the most powerful question of all, does it make sense? This is your ultimate defense. So much of what is presented as statistical fact crumbles under the weight of simple common sense. When you hear that life expectancy is 63, so a retirement age of 65 is a scam, does that match the reality of the world you see around you, filled with people in their 70s and 80s? No. And that simple check is often all you need to spot the lie. Learning to apply these 5 questions is like developing a superpower. It allows you to move through the world with more clarity and less fear. It is the very essence of critical thinking, a skill that is not just useful for your schoolwork, but for every decision you will make for the rest of your life. That was a summary of How to Lie with Statistics by Darrell Huff. We've certainly touched on the major tricks and traps today, but I'll be honest with you, a summary can only ever be a map. The real treasure is found when you explore the territory yourself. The true magic happens when you read the book and a particular story or a simple phrase from Huff himself clicks in your mind in a way you didn't expect. This summary is meant to be a starting point, to help you decide if this journey is for you. If anything we've discussed today has sparked your curiosity or made you see the world a little differently, then I wholeheartedly encourage you to grab a copy. Reading it isn't just about learning. It's an experience that can genuinely sharpen the way you think for a lifetime. Also, if you found this summary valuable, I would be so grateful if you would hit that like button and subscribe to the channel. That way, you won't miss our next exploration into another life-changing book from the billionaire's bookshelf. Let's keep learning and growing together.